Okay, so a lot easier this time. We're going to basically learn some vocabulary, and we've already talked about this, like I introduced it before it came into this section. But here's some words: consistent, inconsistent. So this is just the mathematical term, consistent and inconsistent, for do the lines ever cross or do they not cross? So consistent means there is at least one solution. And inconsistent is another way to say there is no solution. So when we were graphing these, like visually, consistent means they meet. Inconsistent means they don't. Or consistent could also be that weird scenario where they're actually the same line because they do meet, like they do cross. Like they have a point in common. It's just that in this weird scenario they have all their points in common. In this scenario they have a single point in common. But if they don't meet at all, that's called inconsistent. And if they do meet, whether everywhere or just in one point, that's called consistent. All right, then two more. Dependent and independent. Independent. It's harder to spell on the board. Okay, so dependent, that's the situation where it's actually the same line. That's this situation. It's the fancy term for it turns out they had infinite solutions. Independent means they did not have infinite solutions. So that could be either this, or it could be this situation where they have no solution. So either one or none. It just means they're not exactly the same line. So every time we solve one, we can use one of those words and one of these words to describe it. So this is just a vocabulary lesson. We're still going to solve some systems, but they're just, instead of saying what's the solution, they'll say like, is it independent or dependent? Is it consistent or inconsistent? But the work actually stays the same. So let's put one up there. Put it up here. These two lines cross at exactly one point. Consistent or inconsistent? Consistent, because they do cross. Is it dependent or independent? Independent, because they're not exactly the same line. So this is consistent and independent. You see, each scenario can have two names. How about if they're parallel? Consistent or inconsistent? Inconsistent because they don't cross. Independent or dependent? Independent because they're not. Dependent is just for when it's exactly the same line. So this is independent. And then how about if they turn out to be the same line? Consistent or inconsistent? Consistent because they do cross somewhere. Independent or dependent? Dependent because they're actually the same line.
If it's dependent, does it have to be consistent?
Yes. Like those two have to go together because if they're the same line, then they definitely cross. And then really this is always, you know what I mean, it has to be. Well, no it doesn't. Okay, so in your work, which is, I'm going to write up here for the purpose of the camera, 4.6, page 186, we're doing 5 through 20, all of them. In the first section, it just says, are they consistent or inconsistent? So you saw that and you just, is it consistent or inconsistent? When it's not a picture, what will that look like? Like what if it's not a graph? Because it won't be. So we'll be trying to solve our little system of equations. And what we'll get to in the end, we talked about this before. If you get an answer, this is a normal scenario. If you get just a regular old answer, these are consistent. They cross. If you get this business, if you get an untrue statement, do you remember talking about that before? Untrue statement means no solution. It means they don't cross. That's what inconsistent looks like. A false statement, inconsistent. If you just get a normal answer, that's consistent. That's the situation we're used to. Okay, how about independent and dependent? If you just get a normal answer, what we're used to, the regular situation, that is independent. Because what we've been doing up until now is this situation. They cross at one point, but now we're getting into the one where it's something weird happened. So what will it look like if it's dependent? You'll get a true statement. Something that's just always true. It's usually zeros. So 7 equals 7. So we'll try to solve it. And if it comes down to a true statement, then it was dependent. Well, I want to try to do a little simple one. Okay, 2x plus 3y. I'm going to drag this over with me. Come on over, friend. Have a close-up of my elbow. All right, 2x plus 3y equals 1. 4x plus 6y equals 2. We can solve it however we want to. What do we want to try? Anybody got an idea?
You just.
I wouldn't try substitution here because none of these are alone. You know what I mean? And so it's going to be hard to do substitution. Multiply the top by -2. I like it. -4x minus 6y, -2, 4x. Do you see it already? Wait, this one didn't change. What happens? Do you see it? The true statement is just a fact. 0 is equal to 0. Those were the same line. So this system is dependent. That true statement, that's dependent. So that's what it's going to look like when you're trying to solve it. Like you're going to do it the way you normally do, but your answer's not going to come out the way it normally comes out. It'll look like something weird. Okay, how about, oh, that's a system of 3, and I don't want to. Let's try. 3x minus y equals 2, and 6x minus 2y equals 3. Here's another set. Make sure she can see. What you want to do? Anybody got a plan again? Come on, Brewer. Give me a plan.
Multiply times 3. -3, I'm sorry.
-3, and then wait.
Would it be
No, because then that'll be 9 and that'll be 6. What you want? Try again.
-2.
-2. Okay, then that'll be -6, and that would be +6. Okay, so I'm going to do this one by -2. I get -6x plus 2y, -4. You might already see it. Do you see how this side matches, but that side doesn't? So when we do this, we get 0, 0 equals -1. That's a false statement. This is not ever true, so this answer is inconsistent. It's no solution. Nothing will ever make this statement true. There is no solution. Everything makes this solution true. It's just always true. So this is infinite solutions that goes along with dependent. No solution goes with inconsistent. So all they're going to ask you, instead of what is the solution, they'll ask, is it consistent or inconsistent? Is it dependent or independent? So you're doing 5 through 20, all of them, asking questions as you go, and then you're going to have a good weekend. Have a good weekend. Hope you're having fun over there.